Welcome everyone. In this video, we want to talk about conversion of angular velocity. And if you can remember, we've said that the standard unit for angular velocity is radians per second. But it can also be expressed in other units. As you can see, we can have it in revolutions per minute, we can have it in revolutions per second, and so on. So it is important to know how to do the conversions. Again, I would not like you to memorize any of this formula. We are going to use a more simplified method of doing the conversions. Okay? So all that I want you to know for now is that you can be given the angular velocity in different units and be asked to convert to other units. It is simple if you know the technique that you have to apply. Rules are first, try to convert time, okay? We will convert time into what is needed. Then we convert the angular displacement. Okay, remember the angular velocity is the angular displacement divided by time. So the first thing you have to do to make it easier for you is to convert time, then later you convert the angular displacement. Reminder, time can be expressed in seconds, in minutes, in hours. So it doesn't matter. You have to know that 60 seconds is equal to 1 minute and 60 minutes is equal to 1 hour and 3,600 seconds is equal to 1 hour. So you should be able to remember these always. So now let's try to do the following conversions. Question A, we want to convert from 30 revolutions per minute to radians per minute. Question A, convert 30 revolutions per minute to radians per minute. So we have 30 revolutions per minute. How do we convert it to radians per minute? If you look at the time, we realize that there is no change. It is just in minutes. So which means we just have to convert revolutions to radians. Now we know that 1 revolution is equal to 2 pi radians. So what is 30 revolutions then? 30 revolutions will be equal to x. Now let's cross multiply. That will be x times 1 revolution is equal to 30 revolutions times 2 pi radians. To find x, we divide both sides by 1 revolution. This will cancel this, revolution cancel revolution. So it means x is equal to 30 times 2 is 60, so that will be 60 pi radians. So we are able to convert 30 revolutions into radians, which is 60 pi radians. So therefore, 30 revolution per minute will be equal to 60 pi radians per minute. So the unit in minutes does not change in this question. Moving on to question B, we want to convert 12 radians per second to revolutions per minute. Convert 12 radians per second to revolutions per minute. Okay, so it is 12 radians per second. If you want, you can say 1 second. We want to convert it to revolutions per minute. So if you look at the time, it has changed its units from seconds to minutes. So how do we first convert the time to minutes? Remember that 60 seconds is equal to 1 minute. Okay, so we need to use this and express it in fraction so that we can multiply it with this. Now the question is, if we are to express it in fraction, is it going to be 60 seconds divided by 1 minute or 1 minute divided by 60 seconds? Well, we have time here expressed as a denominator. So in order to be able to cancel it out, we have to use where we have time as a numerator. And in that case, it is the 60 seconds divided by 1 minute. So it means I have to multiply this by 60 seconds divided by 1 minute. Because otherwise, you will not be able to cancel the second out. So if it is in this form, only then you will be able to cancel the seconds. So these seconds cancels these seconds here. So now what will we have? We will have 12 times 60, which is going to be 720 radians per minute. Okay, so what do we do now? We want to convert the radians to revolution. So we know that 1 revolution is equal to 2 pi radians. So what will be 720 radians? 720 radians will be equal to x. Then we cross multiply. We will have x times 2 pi radians is equal to 1 revolution times 720 radians. So to find x, we divide both sides by 2 pi radians. So this will cancel this. Radians will cancel radians. 2 goes once into 720 is 360 times. So x will be equal to 360 divided by pi revolutions. So that is what is x. So our answer is now in revolutions per minute. So therefore, 12 radians per second is equal to 360 divided by pi revolutions per minute. Question C, we want to convert 5 revolutions per second to radians per minute. So we have 5 revolutions per second, and we want to convert it to radians per minute. Since time is in different units, we have to convert time from seconds to minutes. We know that 60 seconds is equal to 1 minute. So if we should express this in fraction, is it going to be 60 seconds divided by 1 minute or 1 minute divided by 60 seconds? Well, we decide that based on what we have here. Seconds here is a denominator, so we have to use a numerator here. Otherwise, we will not be able to cancel seconds. So that is to say, this is the one we're going to use. So we will say multiply by 60 seconds divided by 1 minute. So seconds will cancel seconds. 5 times 60 is 300. So that will be 300 revolutions per minute. Okay, now we have been able to convert it into revolutions per minute, but the answer has to be in radians per minute. So which means the revolution that I have here is what I have to convert to radians. We know that 1 revolution is equal to 2 pi radians. So what will be 300 revolution? That will be x. We cross multiply. We're going to have x times 1 revolution is equal to 300 revolutions times 2 pi radians. To find x, we divide both sides by 1 revolution. This will cancel this. Revolution cancels revolutions. So what are we going to have? We're going to have x is equal to 600 pi radians. So it means this 300 revolutions is 600 pi radians. So our answer will be, therefore, 5 revolutions per second is equal to 600 pi radians per minute. Okay. Moving on to D, 90 revolutions per minute to radians per seconds. So we have 90 revolutions per minute, and we want to convert it to radians per seconds. The first thing we have to look is if time is in different units. Here, time is in different units. We have to convert from minutes to seconds. So what is the relationship between minutes and seconds? We know that 60 seconds is equal to 1 minute. So how do I express that in fraction? Is it 60 seconds divided by 1 minute or 1 minute divided by 60 seconds? Well, to be able to cancel minute here is a denominator, so I have to multiply it where it is a numerator. So that is going to be this. So we're going to use times 1 minute divided by 60 seconds. So with this, minute can cancel minute, okay? So we will have 90 revolutions divided by 60 seconds. And if we simplify that, 90 divided by 60 is 1.5. So that will be 1.5 revolutions per second. Now, time is in seconds, but the angular displacement has to be in radians. So that is what we're going to do now. We know that 1 revolution is equal to 2 pi radians. So what is 1.5 revolutions? That will be equal to x. We cross multiply. We'll have x times 1 revolution is equal to 2 pi radians times 1.5 revolutions. To find x, we divide both sides by 1 revolution. So this will cancel this. Revolution cancels revolutions. So which means x is equal to 2 times 1.5 is 3. So that will be 3 pi radians. So our answer, this 1.5 revolution is 3 pi radians. So therefore 90 revolution per minute is equal to 3 pi radians per seconds. Okay. E is 30 radians per seconds to revolutions per minute. So we have 30 radians per seconds. We want to convert it to revolutions per minute. We want to convert it to revolutions per minute. The unit of time has changed from seconds to minutes. So we will ask ourselves, how do we convert seconds to minutes? If 60 seconds is equal to 1 minute, then we need to have this in fraction. So is it 60 seconds divided by 1 minute, or 1 minute divided by 60 seconds? Here, seconds is a denominator, so we have to multiply it where we have it as a numerator. So that is going to be this. So it means we're going to multiply it by 60 seconds divided by 1 minute. So seconds will cancel seconds. 30 times 60 is 1,800. So that will be 1,800 radians per minute. So what do we do next? We have expressed time in minutes, but radians has to be converted to revolutions. So what do? We know that 1 revolution is equal to 2 pi radians. So what is 1,800 radians? That will be equal to x. We cross multiply. X times 2 pi radians is equal to 1,800 radians times 1 revolution. So to find x, we divide both sides by 2 pi radians. This will cancel this. Radian will cancel radian. So what are we left with? X will now be 1,800 divided by 2 is 900. Okay, because 2 goes once into 1,800 is 900. So it means our answer will be 900 divided by pi revolutions. Therefore, 30 radians per second is equal to 900 divided by pi revolutions per minute. Moving on to F, 720 revolutions per hour to radians per second. Convert 720 revolutions per hour to radians per second. So we have 720 revolutions per hour, and we want to convert to radians per second. So the unit of time has changed from hours to seconds. So let's first try to do that conversion. We know that 1 hour is equal to 3,600 seconds. So if we should express that in fraction, should it be 1 hour over 3,600 seconds or 3,600 seconds divided by 1 hour? Well, if hour is a denominator here, we have to multiply it where it is a numerator. So that is going to be this, 1 hour divided by 3,600. So multiply by 1 hour divided by 3,600 seconds. So if we do that, hour will cancel hour. So we will have 720 revolutions divided by 3,600 seconds. If you simplify that, you will have 0.2 revolutions per seconds. So the answer is now in seconds, but the revolution has to change to radians. We know that 1 revolution is equal to 2 pi radians. So if you have 0.2 revolution, what is that? That is equal to x. We cross multiply. So we'll have x times 1 revolution is equal to 2 pi radians times 0.2 revolution. To find x, we divide both sides by 1 revolution. So this will cancel this. Revolution cancel revolution. So x will be equal to 2 times 0.2 is 0.4 pi radians. Okay, so which means you can say, therefore, 720 revolution per hour is equal to 0.4 pi radians per seconds. Okay, thank you very much for watching this video. Please subscribe to the channel, like and share the video. In our next video, we'll be solving problems related to circular motion.